Okay, so at this time we are familiar with polynomials, what they mean, what they represent, how to add them, subtract them, multiply, and divide them. And what happens in Chapter 5 is we're going to learn how to factor polynomials, right? So we're obviously starting in 5.1, but what I'd like to begin with is an overview of the big ideas. And then, of course, as we go section by section, we'll start filling in all the little gaps. So for starters, what does it mean to factor a polynomial? Well, it means the same thing if I had asked you guys to factor a number like 75, right? If I asked you to factor a number like 75, basically what I'm asking you to do is to break it up into product. You're thinking, what times what can I multiply together and get 75? So 1 is 3 times 25. So notice I've broken this up into a product. Okay, if you thought about it, I think another one would be 15 times 5, right? Of course, we have kind of the trivial one, 1 times 75. And so that's, again, what we're basically asking you to do when I'm asking you to factor a polynomial. What times what gives us 75? Of course, if I asked you to completely factor, which we're going to be doing, you would basically make sure that all the factors, like right now 75 breaks up into the factors of 3 and 25, but this isn't completely factored because the 25 breaks down more, right? So we'd have something like 3 and 5 times 5, right? Even here, the 15 breaks down more, but if we broke it down, we get 3 times 5 times 5. So we called that prime factorization back in the day. Now we're just calling it completely factored. You can begin to see why that's the trivial case, because one of the factors actually involves the very thing I'm trying to factor. That's, technically speaking, it's a right answer, but we're trying to break it down, right? Not reuse it. So be careful with that. All right, so that's what it means to factor. So for us, I'm going to take a polynomial, let's say x squared minus 49, right? So I have a binomial of degree 2. And the question now is, when I'm asking you to factor it, what times what, right? What two things can I multiply to create that situation? And if you're paying close attention to the last chapter, this is basically our difference of squares. I can write this as x squared minus 7 squared. And if we reverse that process, I know I need an x plus 7 times an x minus 7. Of course, how can you check to see if I got the right answer? Just FOIL it back together, right? X times x would give us x squared. The outer would give us a negative 7x. The inner would give us a positive 7x. And then last times last gives me 49, negative 49. Those cancel out, and lo and behold, there you go. So this binomial times this binomial, their multiplication creates that binomial there. So we just factored the binomial. So again, to factor a polynomial means we are breaking it up into a product. What polynomial times what polynomial creates that? So there I kind of use the difference of squares formula. Of course, we're going to start looking at things that look more like this. 2x squared plus x minus 6. This is a classic degree 2 trinomial. So again, the question is what two things can I multiply, right? What times what creates that trinomial right there? All right, and so if you guys sat and thought about it, or if you've done some of this stuff before, maybe you could come up with a guess. But how about I reserve this for later, right? Because this is basically what we're going to be talking about throughout this chapter, right? So just, again, I'm hoping I gave you an overview of what it means, right? I'm going to give you a polynomial, and you're trying to think what two things, or maybe even three things, right? Because maybe it breaks down more. What can I multiply together to give me that trinomial, right? We know these two things are what I multiply to give me that binomial, and then we know these three factors are what I multiply up to give 75. So that's the goal in this chapter. We're basically taking a polynomial and we're breaking it up, right? Break up into a product. What times what gives me the polynomial? Okay, so now that we know what we're going to be doing, what I'd also like to share with you guys is a factoring flowchart. We're going to learn a lot of different techniques, tons of them, all right? And so I wanted to start this early. Obviously, I'm going to have to fill in the gaps, but when you're factoring anything, right, whether it's this or that or anything, you should basically break it up into two parts, and then you're going to keep recycling through them. The first thing you should always ask yourself is, can I factor out a GCF, right? If it exists, you do. If it doesn't, you just move on. So factoring out the GCF is how we usually want to start. As you will see later on in this section, it's the easiest thing to do. And then we ask ourselves, after we've handled the GCF, we now ask ourselves, how many terms am I looking at? And the number of terms I have drives the factoring technique we use. So if we're dealing with two terms, we're actually going to use a pattern, a difference of squares pattern, a difference of cubes pattern, and a sums of cubes. Of course, we've seen the difference of squares pattern. I just used it up here, right? But these two are new to us. But if I have a two-termer, then we're looking for a pattern to use. If I have three terms will typically be a degree 2 trinomial like this guy here. The two techniques we'll use is the AC method or guess and check. All right, and then last but not least, if we have 4 or more terms, right, 4, 5, 6, whatever, if we have 4 or more terms, then the technique we're going to use is grouping. And so you're going to see this over and over and over again. Of course, my job now is to tell you, well, what is a GCF and how do we factor it out, right? What are these two new patterns and how do I use them? What in the world is the AC method in guessing and checking, and what is grouping? That's basically what Chapter 5 is all about. But hopefully there's a flow chart on how to organize all the techniques that you're going to be learning. So we got a lot of work to do. Let's get to it.